Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, Section 82. We'll be presenting about soil properties and soil investigation report.
Introduction. Soil is the loose surface material that covers most land. It consists of inorganic particle and organic matter. Soil provides the structural support for plant use in agriculture and is also their sources of water and nutrient. Soil vary greatly in their chemical and physical properties. Processes such as leaching, weathering, and microbial activity combine to make a wide range of different soil types. Each type has particular strengths and weaknesses for agriculture production.
There are 4 objectives. First is to identify and classify local soil type based on their properties and evaluate their suitability for construction work such as foundation, embankment, and pavement. Second is to conduct a systematic investigation of subsurface soil condition in order to determine the soil profile, strengths, and other relevant properties for safe and efficient construction design. Third is to observe the physical characteristic and origin of each soil type. Lastly is to assess its soil engineering behavior and performance in relation to construction needs like stability, drainage, and compaction.
I will begin with the soil identification and origin. Beach sand is a type of coarse soil that does not stick together. It is commonly found along shorelines. For this study, the sand sample was collected from participants in Kuantan, Pahang, which is well known for its natural sand supply. The particles in this sand range between 0.06 to 5 and 2 millimeters and are mostly made of silica or limestone, depending on the nearby rock formations. Because beach sand is non-plastic and has fine texture, it is often used in geotechnical engineering to improve the performance of clay soil. When mixed correctly, it is increased soil density and reduced plasticity, making the soil stronger and more stable. Okay, now let's move on to the physical characteristic of the beach sand. First, the texture is medium to fine. Although it is raw, it still feels comfortable to walk on. The color is usually light brown due to iron oxidized and there is noticeable smell. Next, the plasticity is very low. The sand cannot be molded even when mixed with water. In terms of compaction and cohesion, beach sand naturally lack cohesion but respond well to mechanical compaction. This helps improve its stability in construction. The moisture content is usually high as the sand is often in the contact with seawater. It is also moderately porous and highly permeable, allowing water to pass through easily. This makes it suitable for drainage layers or filter materials. Finally, the sample contains minimal organic matter, which does not affect its engineering performance. Okay, now let's look at the engineering suitability of beach sand. As a foundation soil, beach sand is not ideal because of its low cohesion, which makes it prone to displacement. However, if compacted properly, it can still provide support for light structures like footpaths or pavements. As a construction material, it is very clean but loose. The particles don't bind well, so it's not suitable for structural concrete unless it is mixed with angular sand. In terms of drainage performance, beach sand performs very well. It is high permeability, allows water to pass through quickly, which helps reduce water buildup. Before using beach sand for construction, some treatment is needed. It should be washed to remove salt and sometimes mixed with angular materials or binders to increase strength and bonding ability. Lastly, a real constructed example is from Terengganu. Beach sand was used in coastal road construction, where it was washed and compacted to be used as a sub-base layer. This helped improve drainage and solve problems related to salt and soil stability. Okay, that's all from me. Let's move to the next presenter.
Bauxite soil is a type of residual soil formed through the instant weathering of aluminium silicate rocks, such as granite and basalt. This process typically occurs in tropical climates. In Malaysia, bauxite soil is commonly found in highly region of Pahang, especially around Berserah and Bukit Goh in Kuantan, which are well known for bauxite mining activities. The soil is easily recognized by its bright red or orange color, cases by a high iron oxide content. Economically, bauxite is valuable for aluminium production through the Bayer process. However, mining activities can lead to environmental problems such as soil erosion and water pollution. Detailed physical description. First, texture. Bauxite soil varies in grain size from coarse to fine, depending on the degree of weathering. Typically, it is fine grain similar to clay or city clay and crumble easily when dry. Next, color and smell. The color ranges from reddish brown to pale gray, influenced by the mineral composition and oxidation. It usually has no noticeable odor, though it may smell damp or earthy when moisture or organic matter is present. Next, plasticity. This soil shows medium to high plasticity depending on its clay and moisture content. When moist, it behaves like clay, usually molded or raw without cracking. Next, compaction and cohesion. Bauxite soil is highly compressible and easily compacted under pressure. It also has moderate to high cohesion, which help bind two particles together and add structural stability. Next, moisture content. It's retain moisture effectively, especially when undisturbed. This is due to its high porosity, which allows water to be stored within its pore spaces. Next, porosity and permeability. The soil is highly porous but has low to moderate permeability. This means water moves slowly through it, though permeability may increase if the soil is loosely packed. Next, presence as. Bauxite soil generally contain very little organic matter, especially in deeper layer. It may include laterite, gravel, iron, aluminium nodules, small stone, and fragment or partially weathered rocks. Engineering suitable analysis. First, as a foundation soil, bauxite soil is generally not suitable as a foundation material unless properly treated. It has a low bearing capacity, especially when the soil is saturated with water. This makes it prone to differential settlement, which can lead to structural damage over time. Next, as a construction material, arm processes, bauxite soil is not ideal for making concrete or brick. However, after compaction, it can be used as a fill material in construction projects. In some cases, hard bauxite or laterite soil can be turned into earthbrine after being fried and compacted, depending on its properties. Next, drainage performance. The soil has low to moderate permeability, which means that water moves through it slowly. This can lead to water ponding on the surface, especially when the soil is compacted or if there is an impermeable layer beneath it. And the last one, need for treatment or improvement. Before any construction can begin, bauxite soil often require treatment or improvement. This can include compacting the soil in layer, stabilizing it with additive like cement or lime, and install subsurface drainage system to manage excess moisture. In more critical area, engineer may also replace or reinforce the soil with more stable material to ensure safety and durability.
Okay, I want to talk about the gravel. So gravel is often forms from the breakdowns of the rocks like granite, limestone, or basalt through weathering and erosion. That it will turn out to be the small particle that we call gravel. So the gravel itself, the diameter of the gravel is around 2 mm to 75 mm diameter. So the gravel we can be found at construction roadworks such as at bypass or residential areas that for the maintenance of the roads itself. So we use gravel as the base of layer for the pavement because of it has the height permeability and height strength. So we move to the next, which is the detailed physical description about the gravel. So the first one is gravel. The texture of the gravel is have a rough and large particle because the gravel is classification as a coarse, so it's not so smooth. It's not smooth, and then the gravel can easily be fed and be seen. So the next is the color and smell. The gravel has the color of grey. Sometimes we can see brown and reddish. It depends, varies by minerals. But for the smell, it doesn't have two distinct smells unless the gravel itself comes from the organic. And then for the plasticity, the gravel is non-plasticity and not moldable. Sometimes like that. So and then the compaction and cohesion. So the compaction itself, the compaction is very high if the gravel comes with sand, but the cohesion is not cohesion, and then the moisture content. So the gravel is very low and poor water retention. So but the good thing is the gravel can drain water very well. And then the next one is porosity and permeability. Of course, as I know that gravel is very low in porosity and very high in permeability. So the last one is present as. So the gravel is present as typically can be found with stones or pebbles. So in clean construction, gravel usually contains no organic materials. So we move to the next, which is engineering suitability analysis of gravel. In this case, it has 4 points. that I will elaborate, which is the first one for foundation soil, drainage performance, construction materials, and if the gravel itself need for treatment or improvement. So the first one is foundation soil. So gravel have high shear strength and low compressibility. If the gravel is graded very well, it's become very stable for buildings, bridges, or highways. If the gravel is poorly graded, it may need stabilization. So the next point is the drainage performance. So the gravel have very excellent in draining the water, and then the permeability of the permeability performance for gravel is very high, and the gravel can flow the water rapidly. And the next point is construction materials. We use gravel ideal for base or sub base in making roads, railways, or pavement, because it has good compaction and can handle the load very well. And the last point is if the gravel need for treatment or improvement. So in such case, gravel may require treatment if the gravel been contaminated or poorly graded. Also, in such cases, if gravel is washing or grading or also mixing with other materials, such as for example like sand or pebbles, it may be needed for better performance.
Next, I will be presenting about question 2, which is soil investigation. Let's start with introduction to soil investigation. Soil investigation is a vital process in civil engineering to assess subsurface soil, rock, and groundwater condition. It involves field work and laboratory tests to determine properties like strength, permeability, and bearing capacity. This information helps engineers design safe and a cost-effective foundation, plan for slope stability, and manage groundwater. Without proper investigation, project risks such as structure failure will increase costs and a safety hazard. There are 3 objectives for soil investigation. First is to ensure safe and efficient foundation design by providing data on soil strength and settlement. This helps avoid under-designed or overly expensive foundation. Second is to analyze slope stability and prevent ground failure. It helps engineers understand how soil reacts to forces like rain or excavation and whether measures like retaining wall are needed. Third is to evaluate environmental impact and ground condition by identifying hazards such as contamination or expansive soil, allowing for proper precaution to be taken. Next, I will explain about the key element of soil investigation. This element helps engineers understand the ground condition for safe and effective construction. There are 3 key elements. First is soil classification and stratigraphy. This step identifies the type of soil and how they are layered underground. The data is collected through borehole, test pit, and sampling. It helps engineers choose the right foundation depth and type, and also affect design decisions like bearing capacity, expected settlement, and construction technique. Second, we have groundwater condition and seasonal changes. This part of the investigation records the depth of the water table and how it might change with the season. The data is collected using observation wells and piezometers. High groundwater can reduce soil strength and make excavation harder. So this information help plan drainage, waterproofing and dewatering system. Third is in situ and laboratory test data. These include tests like the standard penetration test, SPT, cone penetration test, CPT, Ethelbert limit and soil permeability. These tests measure how the soil behaves under pressure and moisture. The results are important for designing strong foundations, stable slope and long-lasting pavement. They also help reduce risk of failure or unnecessary over-design. In conclusion, soil investigation is essential in ensuring the safety, stability and long-term performance of construction projects. By providing accurate information on ground condition, it helps engineers make informed decisions, design efficient foundation and prevent costly failure or environmental issue. That's all from our group. Thank you.